All right, and next we're looking at finding our slope from a series of ordered pairs. So we're looking at ordered pairs, we're looking for, remember, a combination of x's and y's that will lead us to graphing points. So I'd be graphing here 4 on my x, 6 on my y, and then -3 on my x and 2 on my y. So here I'm just looking at two ordered pairs, and again, without a graph, without a table, how we can find slope. So here we go. Again, remember when we're looking at ordered pairs, if this is my ordered pair 1, 2, that means I have a 1 on my x and a 2 on my y, and I go over to my x and then up on my y to put a point right there, and that is point number 1. And then here I have x is equal to 2, y is 5, so I went over 2 and then up 5 to get to that 2, 5 point. So that's point 2 right there. Now again, we talked briefly yesterday, and that we know that 2 points have to be linear because the only way that would make sense to connect 2 points is with a straight line. We would never go out of our way to make a squiggle line to connect 2 points. We would never make anything curved to connect 2 points. Any 2 points will always be connected by a straight line. Now we determine if it's linear. Maybe if I add a third point, and now that doesn't continue in a straight line, now I know that this is a non-linear equation. But before, when I didn't have that third point, I was just looking between just those 2 points right here, and yes, it has to be linear. So if it's linear, it has a slope, and now we just need to figure out that slope. We talked earlier in class today about slope being rise and run, and also with a change in y and change in x. So we're going to use those same exact things, except now we have two ordered pairs, and we're going to see how they adjust. Your two ordered pairs have been given in an order. I just suggest going in that same order and looking first at how do y's change and how do x's change. So we're looking for this or these ordered pairs right here, and I need to find slope. Rise, we said when we went back talking about these, that was vertical change. That could be up or down. Horizontal change meant run. You run along the ground, you rise up and down. So that is the same thing with our change in y, change in x. Here we're looking to see, do I move left or right or up or down, and how do those things adjust? This one is more applicable towards ordered pairs just because we have x's and y's right here. We don't have to worry about graphs. We don't have to move up and down. We have all the information we need right in those ordered pairs. So again, I'm just going to focus on those changes in y's, changes in x. So first off, if this is my first point and this is my second one, let's see how things change. Here we're going from my y's. I'm actually going to label that as y1 and y2 just for the purpose that is the y point on point 1 and the y point on point 2. No other labeling reason other than just that. And so now I see between my two y's, I have a change of 5. And then I look to my x's, and I see, okay, what's my change there? And I have a change of 3. So now my slope is just simply that, 5 over 3. My change in y first over my change in x. And I just look to see how things adjusted there. So that's a really straightforward way of finding slope. How do my y's change? How do my x's change? You're going to see samples in your book that ask you to find a slope from 2 points. Here is point A, and here is point B. These are 2 points that would exist on a graph, and all you really have to be aware of is that you know that x comes first, y comes second, and x comes first, and y comes second. Knowing that, now all you need to do is find change. So what's my change in y? And then I'm going to put that over my change in x, and that answer is going to be my slope. So I look to my y's first, and I see that from point A to point B, I have a change of 3, and actually -3, because I'm going from 12 down to 9. And then I look to my x's, and I see that I go from 6 to 8, and that's a change of 2. So now my slope is -3 over 2. If for some reason you did those backwards, and you went you looked at the, oops, I'm getting rid of the stuff that I don't need to get rid of. And if you looked at it backwards and you started to look at this piece right here and started to say that, okay, well, what happens if I confuse them and I go, this is my first point, and I go to here? If you get a slope there, that's a growth of 3. 9 plus 3 equals 12. And then you got to go in that same direction. Stay from that point and go to the next one. So now I'm going a decrease of 2. And so now if we look at these, based on what we know about integers, these are the exact same number. So if I'm going down 3 every time I go right 2, that's the same thing as going up 3 every time I go left 2. It would give us the exact same line. This is the preferred answer just because it takes that first point and then goes to the second one. So in your books, just go from first point to second point, look at change in y, change in x.